In the above reaction, 3.9 gram of benzene on nitration gives 4.92 gram of nitrobenzene. The percentage yield of nitrobenzene in the above reaction is -%. ये है बेंजीन, नाइट्रेशन किया इसका HNO3 एंड H2SO4 के मिक्सचर से, तो प्रोडक्ट में आ गया नाइट्रोबेंजीन। तो जो मॉलिक्यूलर फॉर्मूला है बेंजीन का वो है C6H6। ऑन नाइट्रेशन इट गिव्स नाइट्रोबेंजीन जिसका मॉलिक्यूलर फॉर्मूला है C6H5NO2। नाउ अप्लाइंग प्रिंसिपल ऑफ एटम कंजर्वेशन ऑन कार्बन एटम्स, क्या हो जाएगा? 1 मोल ऑफ बेंजीन कंटेन्स 6 मोल्स ऑफ कार्बन एटम। तो ये हो जाएगा, this will not be 1, this will be 6. 6 into moles of benzene is equal to 1 mole of nitrobenzene contains 6 moles of carbon atoms. So this will also be 6 into moles of nitrobenzene. So 6 and 6 will get cancelled. So moles of benzene is equal to moles of nitrobenzene. अब moles of benzene कितना है? moles of benzene हो जाएगा weight of benzene, that is 3.9 gram, divided by molecular weight of benzene, that is 78, and this is equal to 0.05 moles. And moles of nitrobenzene हो जाएगा weight of nitrobenzene, that is 4.92, divided by molecular weight of nitrobenzene, that is 123, तो ये हो जाएगा 0.04 moles. Now जो expected yield है from the reaction वो है 0.05 moles of nitrobenzene, और जो एक्चुअल यील्ड है वो है 0.04 मोल्स। तो परसेंटेज यील्ड हो जाएगा एक्चुअल यील्ड डिवाइडेड बाय थियोरेटिकल यील्ड, एंड दिस इज इक्वल टू 80%। तो यहाँ पे यील्ड ऑफ नाइट्रोबेंजीन हो जाएगा 80%। The number of chlorine atoms in 20 milliliter of chlorine gas at STP is dash into 10 to the power 21. Assume chlorine is an ideal gas at STP. Value of R is given. Avogadro's number value is given. Now PV is equal to nRT. From PV is equal to nRT we get N is equal to PV divided by RT. Value of pressure is 1 atmosphere. Volume is 20 milliliters. So in liters it will be 20 into 10 to the power minus 3. Value of R is given as 0.083. And temperature is 273 Kelvin. Solving number of moles of chlorine in 20 milliliter of chlorine gas is 0.88 into 10 to the power minus 3 moles. Now, chlorine gas consists of chlorine molecules, and each chlorine molecule is made up of 2 chlorine atoms. So, 1 mole of chlorine molecule contains 2 moles of chlorine atoms. 1 mole of chlorine molecule contains 2 moles of chlorine atoms. Therefore, 0.88 moles of chlorine molecules will contain 2 into 0.88 moles of chlorine atom. So, moles of chlorine atoms will be 2 into 0.88. And number of chlorine atoms will be equal to moles of chlorine atom. This will be 2 into 0.88 into 10 to the power minus 3. Into 10 to the power minus 3, as the number of moles of chlorine molecules is 0.88 into 10 to the power minus 3. This is into 10 to the power minus 3. So number of chlorine atoms will be equal to moles of chlorine atom, that is 2 into 0.88 into 10 to the power minus 3 multiplied by Avogadro's number. Solving, number of chlorine atoms is 1.06 into 10 to the power 21. So here the answer will be 1.06 into 10 to the power 21. Hello students. A reaction of 0.1 mole of benzylamine with bromomethane gave 23 gram of benzyl trimethyl ammonium bromide. The number of moles of bromomethane consumed in this reaction are n into 10 to the power minus 1. When n is equal to, we have to find the value of n. Now this is the balanced equation for the reaction. Moles of benzylamine is 0.1 mole and the weight of benzyl trimethyl ammonium bromide is 23 gram. and molecular weight is, the number of carbon atoms is 10. So weight of carbon, total weight of carbon will be 10 into 12. 12 is the atomic weight of carbon, so this is equal to 120, plus number of hydrogens is 16. Atomic weight of hydrogen is 1, so 16 into 1. So weight of all the 16 hydrogen atoms is 16. Number of nitrogen atoms is 1, atomic weight of nitrogen is 14. So 120 plus 16 plus 14 plus atomic weight of bromine, that is 80. So molecular weight of the product is 230, and moles of benzyl trimethylammonium bromide will be weight divided by molecular weight. So number of moles is 0.1 mole. Now according to the balanced equation, 1 mole of benzylamine reacts with 3 moles of bromomethane. So 0.1 moles of benzylamine will react with 3 into 0.1, that is 0.3 moles of bromomethane. This can also be written as 3 into 10 to the power minus 1 moles. So the value of N is 3. Hello students. Complete combustion of 3 gram of ethane gives X into 10 to the power 22 molecules of water. The value of X is. Now this is the balanced equation for the combustion of ethane. So from the balanced equation we can see that 1 mole of ethane gives 3 moles of water. Now weight of ethane is given as 3 gram. So moles of ethane will be 3 divided by molecular weight of ethane, that is 30, and this is equal to 0.1 moles. So if 1 mole of ethane gives 3 moles of water, then 0.1 mole of ethane will give 0.3 moles of water, and so the number of water molecules will be moles of water multiplied by Avogadro's number. So the answer is 18.069 into 10 to the power 22 molecules of water. And to find the molecular weight of ethane. In ethane the number of carbon atoms is 2. So 2 into atomic weight of carbon, that is 12. This is equal to 24. Number of hydrogen atoms is 6. So 6 into atomic weight of hydrogen, that is 1, and this is equal to 6. So molecular weight of ethane is 30. So answer here is, the value of X is 18.069.